Hi everyone, my name is Bhavishya, and in this lecture we will learn about RIP version 2's more property in detail. We will cover from new field in our router entry. We'll see how authentication works in RIP version 2, how it supports. We also see that RIP version 2 also supports auto summarization, and we will see that how can we remove auto summarization. Then we will see how to configure RIP version 2 and how to remove it, and so on, so more. So let's begin. So the very first thing that is, we have a new field here that is route tag. Okay, now what does this mean? So this is used to distinguish between internal and external routes within an autonomous system. Okay, sounds complex, right? Let me clarify it. So, especially we use it to redistribute routes between RIP and OSPF. Let me take an example. Okay, as you can see in this topology, here router 1, router 2 and router 3 is configured with our routing information protocol, and here R3, R4, R5 is configured with OSPF protocol. Okay, so now when we talk about, let's suppose R1, we'll check the entry in R1 about 20 network. So it will say R in IP route, in show IP route, it will say R, then this 20.0.0.0 network, then administrative address, then hop count 1, and then it will say that okay, I learned it via this I, IP address 10.0.0.1 on this particular port, right? Now, this is what we have learned through a RIP. Now let's suppose, now as you can see, here it is configured with RIP and here it is configured via OSPF. So let's suppose PC1 wants to communicate with PC2. So for that to happen, we have learned this information via OSPF. So there has to be a redistribution happening between RIP and OSPF so that we can learn this information. And this has been made possible by our route tag. Right, and that also indicates when we learn this information in the routing table, we will see R plus something and R with something. We'll learn in a bit what is that something in OSPF lecture. That indicates that it's an external route, a router that is outside of the RIP autonomous system. Right, so this was the use of our router tag. Now let's come to our authentication. Now in RIP version 2, it supports authentication. So in RIP version 2, authentication happens using 20 bits of packets, right? Which reduces the network advertisement per update from 25 to 24, right? And the third point is auto summarization. So our RIP version 2 also supports auto summarization, right? So it will, if there is a subnets all over our router, and when there is a chance for a router to advertise it further, it will send only the major network, not all the subnets. Let's take an example. Now here in this example, as you can see, we have different IP addresses with subnets, and when R1 is advertising about its connected network to R2, this is what it is advertising 192.168.10.0, not all the networks, because auto summarization is on. And the reason why we have configured auto summarization here, not no auto summary, because let's suppose instead of PCs we have routers, and now that routers are connected to big networks or a larger network. Now when it comes for R1, not just this but all of the PCs, instead of PCs, routers, and then connected to larger networks. And now all these are connected to our R1, and then R1 is advertising it further to R2. That will cause our network will become heavy, it will become congested, and also that will cause so much of our bandwidth. And to save our bandwidth, we use auto summarization, right? There is also other way, and this is how we remove auto summarization. Router rip and then no auto summary. That will remove it. But there is no use of that. Let's suppose we used it, and now instead of this, initially when auto summarization was on, this is what it was advertising. But after this, we have configured in rip version 1 to stop the auto summary. This is what it will give us. Look, this is what it will advertise because now we have reconfigured it and we have stopped the auto summary. So every network connected to router 1, it will, every subnet to be specific, it will advertise it to R2, and these are the entries. Now, this is a way how we configure our rip version 2, right? In configuration mode, we type router rip, and then after in router configuration mode, we type the version 2, and then we get the network. And to remove our version, we use this command, router rip and then no version. And when we configure rip version 2 instead of 1, this allows the movement of subnet mask to integrate with our network update, or this allows the movement of subnet mask along with the network update, right? And also from this topology we will learn default route in RIP. So before jumping into it, as you can see in this topology here, this particular R3 with switch connected to it, this is a special type of router, right? This is known as step router, where there is just one way to go out, right? And usually we use for our default route, we choose this type of router, that is step routers. But now I don't want to make it default route, neither this, neither this. I want to make this as a default router, right? Which is connected to R4, and then there is cloud connected to, and somewhere there is ET.network I want to reach. Okay. So now what will happen? I will go to R1 and I will configure IP route, IP address 0.0.0.0 with subnet mask 0.0.0.0 with next hop that is 40.0.0.1, this particular, right? But this is what we were normally doing, default route, and for that we have to configure to R2 and R3 as well, but now we will not do it. Instead what we'll do is we will configure RIP in router 1. We'll go with router RIP, and then in the router configuration mode we will type default information originate. After this, what will happen is it will start propagating, R1 will start propagating about default route information to R2 and R3. So now instead of manually configuring it, now in the R2's R2 table, routing table, it has the information about default route, that to when we don't have any place to go or no direction to go, we can go via this default route, which is connected to R1 with this next hop 40.0.0.1, where there is this network connected and many more, right? And now the last thing, that our RIP version 1 uses broadcast. In layer 2 it uses OLAFs, that is an In layer 3, it uses all ones, that is 255.255.255.255. But when we talk about reversion 2, it uses multicast, right? So the multicast IP address that it uses is this 224.0.0.9. So this is a multicast address that it uses. This belongs to our class D address. And this part, if you see from here to here, this is common, and this is also that we use in our OSPF, right? And when we talk about the MAC address, so it uses a multicast MAC address that it is this. So here also this part is common. From here to here, this part is common. We also use it in OSPFs. So yeah, this was it for this lecture. I hope you enjoyed. See you in the next one. Bye bye.